currently here at St. Lucie County's Regional Fair and Engineering Fair here at IRSC in the Kite Building. And behind me, what you see is all of our students district-wide that are doing science projects that have already come to a certain level in the contest and the competition. And so these are basically our best science projects here, and it's absolutely fabulous.
Black, and this is my project at Debate Wood or Aluminum. I did this project because I'm particularly interested in the physics of baseball and softball and bats. My hypothesis was that the aluminum bat would hit the baseball farther on the sweet spot, above the sweet spot, and below the sweet spot. The sweet spot is this part of the bat where you get the maximum pop and it makes the ball have a greater distance. And so going through this experiment, I encountered many challenges, such as measuring the distance of the ball from home plate. And this is my data that I collected, and I concluded that the aluminum bat did hit the ball farther on the sweet spot and above the sweet spot. However, the wooden bat hit the ball farther below the sweet spot. So my hypothesis was accurate.
I'm Matthew Pinto from Northport KA. My experiment was to see which material protects you the best. I put different amounts of cornstarch and water in bags and dropped nails on them to see which one had the smallest penetration depth. And it turned out that the bag with 1/4 cornstarch and 3/4 water would protect you the best because it compacts fast when something hits it, and this could be used to make vests that protect you but are easy to move around in.
My experiment was comparing monofilament fishing line to braided fishing line. My hypothesis was that the braided fishing line would be stronger than the monofilament because braid is multiple strands in one line. Therefore, I thought it would make it stronger. And monofilament is one solid piece of fishing line. In the end of the experiment, the braid was stronger. What I did is I had a scale, tied it to the actual line itself, and put it on a weight, and then lifted it. And whenever the line snapped, it would pull the scale down to where it would pull the mark down to where it broke at. So averaging everything out in every experiment, every trial, I did 5 trials of each. And every one, braid always came out on the top, so my hypothesis was correct.
My name is Stephanie Medina. I'm from Northport K-8. In my project, I had to determine the difference between viewing an object and the distance away from it. In the experiment, I used 2 hula hoops as us on Earth, and I used a distant object as the stars. And I calculated the distance from each one, and after every trial, I would move 2 meters forward, and I would record the difference that it was from the one before.
My name is Justin McKinney. I'm from Manatee Academy K-8, and for my project Interactions of Light, I shined a laser pointer onto clear glass surfaces of different textures to see if the reflection would change between 90 degrees and 45 degrees, and see if the texture changed the angle of the reflection.
All right, my name is Michael Boggs from Manatee Academy, kindergarten through 8th grade. My project was on melting ice cubes in different insulators to test which insulator could prevent the ice cube from melting the least.
Isabella Nazario, and I go to Palm Point Educational Research School. My project was to see if different string tensions and different chord surfaces affected the bounce of the ball. So what I did was I went to different tennis courts, and I did 3 trials for 3 different kinds of tensions: 50 pounds, 52 pounds, and 62 pounds. So my results were that if you went to a grass court with a racket with 52 pounds of tension, that it would affect the ball more because of the uneven surface of a grass court, because it gives the ball a higher pace.
My project is the absorption of radiant energy by different colors. And basically what I did was I took the temperature of 5 different kinds of sheets of paper, and then I averaged them out, averaged out the results, and then I put them through the Stefan-Boltzmann equation to figure out how many photons were emitted per second for each of the colored sheets of paper. So then after putting it through 3 equations, I got that black absorbed the most radiant energy over a period of like 1 second. So on like hotter days, it's better to wear a lighter color such as yellow that absorbs the least amount of radiant energy, because that radiant energy is bad for your skin, and eventually it can cause cancer. So that's basically what I did, and that's my whole project. I'm from Okemuk.
My name is Connor Stottlemyre. I go to Palm Point Educational Research School. I did my project on, does the temperature affect the strength of a magnet? So what I did was I made a homemade magnet, and then I put it in boiling water and dry ice. And I figured out that dry ice will affect the strength of the magnet by making it stronger and making it more magnetic. So that was my result.
My name is Lane Rashid, and my school that I'm from is from Alapata Flats. And the project that I did was about testing seeds, the germination of seeds after being frozen. So what I did was I basically I took like various amount of seeds and put them in separate piles. I placed them in 10 piles each, holding 30 seeds. And then once I did that, I placed them in the freezer for about a week. And then when I finished with that, I took them and I filled half the bags with water. Once that was finished, I put them in a dry area for up to about a week and a half, and then I observed what happened, and then I emptied the water, and I put paper towel in each bag, and I placed the seeds in a dry area and waited for them to germinate, and I wrote down the observations that what happened after. The kidney beans germinated the most, and I noticed that after the beans were soaked in the water, some of them got swollen.
We are so thrilled to be here today and so appreciative to all of the judges that come together to support our outstanding student projects. Quality of work is exceptional, and I would like to thank everyone in the Office of Teaching and Learning who put this together, as well as Indian River State College for all of their help and support and use of this amazing facility.
Alright, my name is Hector Pena, and my school is Palm Point Tradition. My project is about which bat is better, aluminum or wood. And with the 5 trials that I did, with the aluminum bat, it hit a farther distance. So when I remember that in the baseball league, they couldn't use the aluminum bat, so it must be because of that. They use a lighter force with aluminum bat, so it hit more force. What did I find? That the aluminum bat hit a farther distance than the wood bat with a baseball bat.
I'm Alicia Solis from West KK8. I did this project with Peyton Briglia and Brianna Jackson. It's called Gravity Growth. We wanted to know if the gravitation changes associated with the phases of the moon contribute to anti-gravitropic plant growth. And our hypothesis was that if we conducted an experiment to see if it did, that it would affect anti-gravitropic plant growth. So we had 3 different colors, and after every phase of the moon, we measured from the soil to the nearest leaf, to see if any changes in growth have occurred at night. So after 3 trials, our conclusion was that the data did not support our hypothesis, and anti-gravitropic plant growth does not contribute to the phases of movement.
My name is Ariana Thiel. I go to Lincoln Park Academy and I'm in 8th grade. My project is on hydroponics. I wanted to test how much rabbit feces is best to grow plants hydroponically. My conclusion was that 355 milliliters is the best to grow plants hydroponically. We also tested the water for nitrates, hardness, pH, and alkalinity and chlorine. For the first couple of weeks, trough C and D had the same exact water testing. My theory is that because the plants were using the nutrients, they used it all to the point they became plain as water. And that is my project.
My name is Shashima Haraj. I attend Northport K8. I'm in 6th grade, and this is my science fair project. It's all about personal flotation devices, or PFDs. The real problem is that if you're stranded in the ocean and you can't swim, and all you have are 3 PFDs. One that is air inflated, the other that is insulated with styrofoam blocks, and the third which is insulated with shredded styrofoam. Which one would you use? My question is that which material is more efficient in personal flotation devices, air or styrofoam? The hypothesis is if foam blocks are used in PFDs, then they will float higher because they're less dense and more efficient. The materials that were used in this project are styrofoam, shredded styrofoam, air, Ziplocs, water, and different weights. The variable that will stay the same is the water level each baggie is placed in. The variable that will differ is the material that is placed in each baggie. The procedures, they're really simple. Step 1, fill each baggie with the material. Step 2, place the baggie in water. Step 3, place different amounts of weights on each baggie. And step 4, record the data. The data analysis. The data that will be collected in this experiment will be qualitative. It is qualitative because others can repeat this experiment and get similar results. The experimental group will be the Ziploc baggies with the different materials, while the control group would be the same water level used. The data chart will be a linear graph. The x-axis is going to be the different weights, while the y-axis is the motion of the PFDs. As you can see here, we have the 3 PFDs. The one on the left is your shredded styrofoam, the one in the middle is the air PFD, and the one on the right is the styrofoam block. In the second picture, we have different materials or different weights on top of each PFD. And then you can see here we have a can of Coke on top of the shredded styrofoam. In conclusion, my hypothesis was incorrect. The contained shredded styrofoam proved to be the best material for the PFDs. It was capable of holding all the weights placed on it, so due to the molecular structure of the shredded styrofoam, it's the best material for PFDs.
My name is Nicholas Stang. I'm in 8th grade from Lincoln Park Academy. My project is on how water quality affects the abundance and diversity of keystone species in the Indian River Lagoon, and how that trickles down to affect the abundance and diversity of these fish, the estuarine animals living in the Indian River Lagoon. To measure the estuarine animals, I used this fish cam, which is a camera held at about 30 centimeters above a grid with 1 centimeter mesh to measure how big the fish were. For the seagrass, I used this 5-meter transect line with measurements every 0.5 meters to hold it down in a grid to measure every 10th meter along these weight system. For the mangroves, I used the same transect line, except I extended it 5 meters and then turned it around and measured another 5 meters on the other side of the person holding the transect line. For water quality, we used a year's supply of data from the LOBO, Harbor Branch LOBO system, land, ocean, biogeochemical observatories placed at different positions along the Indian River Lagoon. For this experiment, I found that there was no distinct correlation between the water quality data and the keystone species and how that affected the fish, what I would assume is that some nitrates and phosphates are actually good because they give the keystone species like the seagrass and the mangoes a little boost in growth, but that would also encourage growth in the things that parasitize those plants, that grow and suffocate those plants. So in the short term, it's okay for high nitrates and phosphates are okay for the seagrasses, but in the long term, I would think that they would lead to other problems further down the road.
Science is a study of the natural world, and a science fair project affords a student to explore the natural world, especially in a topic that he or she is interested in, and it is a fabulous learning experience.
My name is Sean and I'm from Lincoln Park Academy. For my project, I did which type of water helps soybeans grow best. My hypothesis was that the water that would work best would be lake water because there was much grass, as you can see, growing around the water. So what I would do is I would plant 3 groups of 24 soybeans, and I would water them with different types of water each day. With these different types of waters, I would measure them every day after that, and then over time they would grow. After about 2 weeks, I would take them out of their pods, and then I would put them on the ground, measure them in a cup. I would subtract the cup's weight from the plant end cup's weight. Then at the end, the results ended up being that the best water to grow is lake water, tap water being second, and bottled water being last in average height. And in the gram weights, tap water has the best, lake water is slightly behind, and bottled water is almost half the amount.
My name is Brandon Quijada, and my project is about which type of bubble wrap is better for fragile objects. The fragile object used in this case was an egg because it's fragile. And I got the idea for the project because when I order, or my parents order something in the mail, something fragile, it usually comes broken. It's only sometimes though. But I want that to not happen ever again. So I wanted to see which bubble wrap was better for fragile objects. My hypothesis was that the bubble wrap with the small bubbles was better. And I tested it, and it turns out that my hypothesis was wrong. It was the bubble wrap with the big bubbles. Because it offered more protection. The bigger bubbles offered more protection for the fragile object.
Hi, my name is Morgan Liberty Juno, and I'm from Forest Grove Middle School, and I've done the project Sprout Out. And what we did is we took 3 different types of cabbages. We used Napa Winter and Purple Cabbage, and we were to cut their stems up into the bottom, middle, and top part of the stems and place them in a bag with a wet paper towel and in a sunny spot, and so to see which ones will produce the most sprouts. And my hypothesis was the Napa cabbage because they're fast growing and grow year round, but in the conclusion, it actually ended up being the purple cabbage middle stems, and I think that's because that they're better in hot and humid environments, while the Napa cabbage is better in cooler and dry environments.
Hello, my name is Jermo Cartagena, and I'm from Okamic. And my project is called Parachutes, Does Size Matter? I got this idea from looking at skydivers that when I'm always in the car, and I always worried about the risk that they took, and depending on the parachutes. I then came to the discovery that the larger the parachutes, the slower that they fly, but the smaller the parachutes, the less time it takes for it to go down. And this is important because in the future, with the NASA and the military, when they're dropping their soldiers or rovers, they're gonna need this so that they can land safely to their designated area. In conclusion, I found that the
that size does matter when talking about parachutes. The smaller that the surface area of the parachutes, the faster that it will drop. But the larger the size, the slower it will drop.
My name is Gabby Andrews from Avocado Flats, and my project is about changing the colors of white carnations. So what we did is we put about 10 drops into a water test tube and put the flower in to see which carnation would absorb the most. And my result was that there is no one flower that will absorb the most water liquid. It just depends on the quality of the flower.
Some fabulous scientists in the works here, so it's awe-inspiring me to see what these children come up with each and every year.
Hi, my name's Tanya Sharif. I'm from Lincoln Park Academy, and my project was, can anaerobic soil disinfestation create a disease-suppressive soil to certain pathogens within Florida? So essentially what I wanted to do in my project is I have two pathogens that are present within Florida called Fusarium oxysporium and Phytophthora cactusi. They're really degrading to our environment and our economy, and they affect a wide range of crops from sweet potatoes to tomatoes to peppers and a lot of the things we see in our kitchen in everyday life. So what I wanted to do is I wanted to come up with a way to combat these pathogens. And the mechanism I used was anaerobic soil disinfestation. And essentially what that does is it removes oxygen from soil, which results in changes within the soil, which are microbial and bacterial and things like that. And as a result of these changes, the pathogens are essentially suppressed and eradicated from the soil. So through my experiment, I had found that both Fusarium and oxysporium responded to these treatments, and Fusarium especially resulted in really reduced disease. When I introduced my treatments to Fusarium, they weren't present. The Fusarium was essentially eradicated from the soil, and that's really important because when we eradicate Fusarium from our environment and our economy, it would really be helpful in a number of aspects, because not only do you go into the grocery store and your plants will be a lower price, but a lot of different aspects play into eradicating Fusarium and Phytophthora from our environment and our soil. So in a nutshell, that was what my experiment was about.
Alexis, this is Madison. Hi. We're from Fort Pierce Westwood, and our project is about lactose in milk. 75% of the world's population, adult population, is lactose intolerant. So we decided to do a project that was
it's relevant to today's society.
To do this project, we had to heat the solution up repeatedly, and then add we had to add ethanol, calcium carbohydrate, and we had to mix it up until
Okay, so we had to heat up our milk, and then we had to add solution to it in order for this little thing in milk called casein to come out, and we had to take that out. And then we had to add some more ethanol, and then we heated that up again, let it cool, filtered it, heated up one more time, and then as it cooled, crystals began to form, and they looked really cool. At the end of the project, it ended up being soy milk that had the least amount of lactose in it. So now we know that, like me, myself, because I'm lactose intolerant, I would rather go for the soy milk instead of things like low fat or powdered milk, which we actually thought low fat would have the least amount of lactose in it, but it ended up being the soy milk.
Hi, I'm Annie Vazo. I'm from Treasure Coast High School. My project was which fruit has the most DNA. The banana had the most DNA in the results. But what I did was I took the Dawn dish soap, put salt and water in it just a little bit, and set that aside. I mashed up the fruits, the 20 grams of fruit, put the Dawn dish soap solution inside, and then mix that together. Once that was done, I put it into a cheesecloth so they would drain and it would just be the liquid, and then the fruit would stay on top. Throw away the fruit, and then the solution that I had on the bottom, I would pour into a test tube. Once that was done, I had the isopropyl alcohol, and I poured that on top, not to mix it though. So once the layer was on top of the fruit, the DNA would come out, and it would be into the alcohol. Now that I took a pipette and took out the DNA, and I put it on a filter. The filter then was put into a it was able to take out the liquid from the filter. Once that was done, I put it on the scale and I weighed it, and then I got my results, which the banana had 0.01 grams twice, and then the other time it didn't have any, and then the strawberry had 0.02 grams, and for the first trial and the second trial and third trial I had none.
Hi, my name is Ethan Yarberry. I'm from Lincoln Park Academy, and my project was on identifying plants with antibacterial properties. I did this by making extracts out of the different plants. Using a cold water extract, I grinded them with cold water in a mortar and pestle, and then I tested those against the bacteria Pantoa agglomerads. I used petri dishes spread with it, and I dipped filtrate discs inside each extract, and I incubated those for 48 hours, and the next day I checked back for zones of inhibition, which would indicate that the plant had antibacterial properties. So one plant actually did. It's the powder puff tree with the scientific name Calliandra hematocephala. And so it had a zone of inhibition of about 9.08 centimeters squared, compared to the control, which I used Simple Green All-Purpose Cleaner, which had a zone of inhibition of 1.01 centimeters squared. And this project is important because antibiotic resistance is becoming a huge problem. According to the CDC, 2 million people are infected each year with antibiotic-resistant bacteria, and 23,000 of those people die. And by identifying plants with antibacterial properties, you could potentially find new treatments to treat these antibiotic-resistant bacteria.
Okay, my project was on companion planting. Basically, I had 3 different types of plants, and I planted them in different combinations together to see if it would affect how they grew. So I had corn, peppers, and peas, and I planted 3 of each combination of those, and then I planted 3 of each by themselves. In the end, it turns out that the corn grew best with all of the different types of plants, and it also helped all the other plants grow.
Hi, my name is Shayna Caldwell. I'm from Fort Pierce, Westwood.
And I'm Ryan Logan, and from Fort Pierce, Westwood too.
Our project is based on Newton's second law, which is F equals m times a. But since we're working with circular velocity, we changed it to F equals m times v squared over time. And basically we worked with 9 different circumferences, and we increased it by the size, and to see how much force is exerted onto the horse's hooves. Which this doesn't also just have to involve horses, it can involve cars or roller coasters. It all just depends what's going in circles. So the biggest circumference size, which is 47.88, which that's also is the less force onto the horse, and that's what we found.
I'm so excited because I used to be a science teacher. So I'm walking around and meeting all of these great students with all of our public schools in St. Lucie County, and I can't tell you how impressed I am by our middle school students and our high school students and the job that they've done. So I hope anybody that's come out here and seen the talent that we have, they should be extremely proud. Also want to thank all of our judges that were here, and I can't tell you how many I've talked to. They've been extremely impressed by what they've seen.
Okay, so Valerie, I'm Donna Mills.
Nice
Glad
to meet you. Hi, Mandy Rowland. Nice to meet you.
Okay, now we want to know about what is energy and how multivitamins and energy drinks contributes to the human body. So can you explain your project for us, please?
Okay, so the idea of my project is to see if energy produced in the human body. So in this one, I have distilled water. In jar B, I have Red Bull. In jar C, I have 5-hour energy. In jar D, I have kids gummies. In jar E, I have Centrum chewable tablets. And here in jar F, I have 1 daily multivitamins for women, and in jar G, I have 1 daily multivitamin for men. So, as the main project and idea was to see if these multivitamins produce energy for the light bulb. So this is just regular water. As you can see, nothing turns on. And here,
And tell us again, vitamin B is
Red Bull.
Red Bull.
Red Bull.
Okay.
Here,
Okay.
and here is 5-hour energy. This one was the one that I concluded that had the highest energy. Here are the kids' gummies. When I first tried this, they didn't turn on. After the 24 hours, they produced a little bit of energy. And the energy increased. Not increased, decreased, my bad. This are the Centrum. They did not turn at all. So I'm curious to see if it turns on now. No energy was produced. And this is for the multivitamins for women. And the men's, when I first tried it, it didn't have that much energy, a little bit. And after the 24 hours, it increased a little bit. Sorry. And it increased compared to what I've done. Okay, my conclusion was that yes, multivitamins and energies do produce energy, but not all of them. Recently, when I was presenting this in my school, this one, after 2 weeks, it turned on. I was really surprised. So it takes time for these multivitamins to dissolve in your body. So I'm amazed about the results that happened 2 weeks later, because all of them decreased. So the conclusion that I made was that 5-hour energy produced more energy, and the Centrum did not produce energy in the human body.
My name is Arabella Tennyson, and I'm from Fort Pierce Central. My project is called Gas and PSI Influencing Distance. I basically took helium, nitrogen, and atmospheric air and filled it in soccer balls at different PSIs, and I kicked it using a uniform force, and I measured the distance traveled. And then I took the averages, and I actually found that the atmospheric air at 9 PSI traveled farthest than any of the other ones, and my hypothesis was proven to be incorrect.
Hi, my name's Jonah Stafford. I'm from Port St. Lucie High School, and this is the types of music and the effects they have on bacteria. First, you take different types of music and you play them to the bacteria, which I collected from a benchtop surface, and you measure them in millimeters. And my hypothesis was that classical music would be the one to win and have the most growth of bacteria. And my conclusion was that my hypothesis was correct, and classical music had the most growth of bacteria colonies.
Okay, my name's Alexandria Pattyfelt. I go to St. Lucie West K-8 school and did a project on tsunamis in water. My project, I basically tested if water depth would affect velocity, and I concluded that water depth doesn't affect tsunami's velocity. So this could help real world problems, because people could narrow down what affects tsunamis. I have data in charts, and it has the averages. 1 centimeter's average was about 0.70 seconds, 2 centimeters to water, 0.69, and 0.50 and 3 centimeters of water got 0.59 seconds of velocity. So the averages didn't really decrease or increase, they just varied, concluding that water depth doesn't affect water velocity.
Hi, I'm Alexis Beans from Fort Pierce Central, and let me tell you about my project. I measured the different SAR levels, which is the specific absorption rate coming from smart meters, and I measured this by getting the amount of electromagnetic radiation that are being emitted from these meters, and then plugging it into the SAR level formula. And I compared this to a data point that I got from a cell phone SAR level, basically saying like, this is the highest amount that our bodies can handle, and then I compared it to the smart meters, and that was actually 3 times the amount that the cell phone is being emitted. And from there, I was able to determine that when these smart meters are in large clusters, say on apartment buildings and low-income housing developments, then they are actually having so much more radiation, and they are actually affecting our bodies way more than if they were by themselves, or say if it was just a cell phone. And so from then, I'd like to eventually start regulating these meters more, and hopefully then run more tests and see how far this electromagnetic radiation is actually affecting us. But there's not enough research right now to actually know how much it truly is affecting our bodies and the way we live and our lives in general. So eventually, that's where I would like to go with this project, but my hypothesis was proven correct, that the more electromagnetic radiation that there is, then the higher the SAR levels will be.
My name is Bryson Lambing.
My name is Gabriel Da Silva, and we're from Mosaic.
And our project is on oil spills, cleaning up oil spills.
We decided to do a couple of tests to see which one would be most efficient and the most successful. And the most successful test was with polyfill. We did 2 polyfill and Dawn detergent with soap, dishwasher soap from Dawn. And we used 1 liter of water and 4 milliliters of corn oil. And we tried, first test was the Dawn, which was less effective because the Dawn only broke the oil up. They didn't really dissolve them, and the polyfill kind of absorbed all the oil up, so the polyfill was the most effective one.
And our conclusion was that the polyfill worked the best, and that if there was an oil spill to happen, we would pull the polyfill behind boats, and it would soak up all the oil. And the Dawn dish soap did not remove the oil, all it did was break it up.